teaching you organic chemistry. Organic chemistry. And in this organic chemistry, I will take you functional groups. Functional groups in organic chemistry. What are functional groups? They are the group of atoms, molecules, or compounds that determine the chemical property of a particular homologous series. They are group of atoms, molecules, or compounds that determine the chemical property of a given homologous series. That is functional group. Homologous series. That is a functional groups. So I will be looking at all the branches of organic chemistry and their functional group. I will start with alkanes. Alkanes are saturated hydrocarbon. They are saturated hydrocarbon. Saturated hydrocarbons. They are functional group. They have the general formula. Functional group. Hello, sir.
Hydrocarbons, two hydrocarbons called action.
They are saturated hydrocarbons. Their own general formula. They have the general formula. Our CN H2N plus 2. They are case. Their own coordinate group is carbon to carbon. Their functional group is carbon to carbon single bond. They are carbon to carbon single bond. They are case. Remember, guys, I told you that with the general formula, CN H2N plus 2. They are members. When n equals to 1, the first member of alkane is CN, C1, H2 times 1 plus 2. That will be CH4. This is our methane. Don't forget. Methane. The second member of the alkanes, when n equals to 2, the second member is C2. 2 times 2 plus 2, that will be C2H6. This is our ethane. With our n equal to 3, we have the C3. 3 times 2 plus 2, that will be C3H8. That will be propane. The number 4 member, when n equals to 4, is C4, 2 times 4 plus 2. That will be C4H10. This is butane. With our n equals to 5, we have C5. H, the formula, times 5 plus 2. That will be C5H12. That is pentane. With our n equals to 6, we have C6. H2 times 6 plus 2. That will be C6H14. This is our essay. With our n equals to 7, we have C7. 7 times 2 plus 2. That will be C7H16. That is our ethane. From polygon. Pentagon, 5 sides. Pentane, hexagon, 6 sides. Hexane, heptagon, 7 sides. Heptene. Our number 8. The next compound is octane. With our n equals to 8, we have C8. 8 times 2 plus 2 is octane. And with our n equals to 9, we have C9. 9 times 2 plus 2, C20. This is nonane. And the number 10 member is decane. This is the members of the saturated hydrocarbon, the alkane group. Remember I said the final group is C, single bond carbon. I take you to another group, the alkane group. I'm taking you to alkene group. The alkene group. The alkene group. The alkenes. Their own general formula is CnH2n. Note that. H2n. And the original group is double bond carbon to carbon. Double bond carbon to carbon. Just like the alkane that I have discussed, they are not saturated. They are unsaturated. If a compound is saturated, it will undergo substitution reaction. That's the alkane group. But for this group, they are unsaturated. Because they are unsaturated, they undergo addition reaction. They are unsaturated. So they undergo addition reaction. Undergo addition reactions. That is the alkenes. Members, don't forget. Member of the alkene. Member of the alkene start from. There's no methane. Don't forget. The first member of the alkene is 18. So the first member is N equal to 2. C2. 2 times 2, 4. This is 18. Another member, this is the first member. This is our number 1 member. Number 2 member is N equal to 3. C3, A6. This is our propene. The alcohol bond, like I've said. The third member is N equals to 4. N equals to 4. And this is our C4, H8. This is our butene. Now, the fourth member is C5, this is C5. H10, this is our pentene. But all I want to know is that in this group, the original group is double bond, not like alkane, which is single bond. They undergo addition reaction because they are unsaturated. I'm going to introduce the final group and their members. So another group is the alkynes. The alkynes, they have the general formula CnH2n minus 2. Their own functional group is triple bond carbon to carbon. Their members start from, don't forget, I said alkene, their first members start from N equal to 2, so also alkynes. Their members start from, their first member is N equals to 2. That will be C2H2, triple bond carbon to carbon. The second member, well, N equals to 3. That would be C3H. 3 times 2 in the formula. 6 minus 2, that is H4. Your triple bond can be anywhere in the ammo between the carbon. If you say triple bond, a carbon with 4 bonds is hydrogen. This count 1, 2, 3, 4 with carbon. This one 1, 2, 4. I will now have 3 hydrogen here to complete 4. This is the form, this is of ethyne. Your own triple bond can also be in the first position here. I will have hydrogen here. Yes, 4 hydrogen already. Well, 1, this is ethyne. Any of these solutions is of ethyne. Our third member with N equals to 4. Our third member with N equals to 4. When our N equals to 4, I will have C4. 4 times 2 minus 2 is 6. So our triple bond can be in the first carbon, I will be hydrogen to make 4. This is 4 already. This is 1. Make 4. This is C4, count now. 1, 2, 3, 4, carbon, hydrogen. 1, 2, 3, 4, 5, 6. That's the and so on and so forth. I'm introducing to the inner formula and their functional group and their structures. Now, don't forget the alkyl group. We call it radical group. The alkyl. The alkyl are obtained when you remove one hydrogen from alkane. They are obtained by removal of one hydrogen from alkane. They are obtained by removing one hydrogen from alkane. Removing one hydrogen from alkane. From alkanes. The name ends with YN. The name ends with YN. The alkyl group. The alkyl group. They are also single bonded. The general formula, like I've said, is CnH2n plus 1. Look at their members. When n equals to 1, I have CH3. 2000 plus 1. This is methyl. Methyl. They don't occur as their own homologous series. Rather, they always act as substituents. They are C2. The second member is C2H5. Ethyl. Another member is C3H7. Propyl. Another member is C4. 4 times 2 plus 1. That is butyl. And so forth, and so forth, and so on. Now, you have seen the hydrocarbons. Don't forget, I told you the meaning of hydrocarbon one of my lectures. I said hydrocarbons, they are the chemistry of carbon and hydrogen only. Hydrocarbon is the study of chemistry, the chemistry that studies carbon and hydrogen only. So remember that constitute the hydrocarbon, they are the alkanes, and the alkynes. Don't forget. If they ask you, what are hydrocarbons? The chemistry that study carbon and hydrogen only. Carbon and hydrogen only. And hydrogen only. They include, look at hydrocarbon. Hydrocarbon includes alkane, and alkyne. They are hydrocarbons. Now, let's shift our teachings to another organic group. We call them alkanols. Alkanols. Let's look at the general formula, the original group, and their members. Once you are familiar with their member, their physical and the chemical party will be easy for you. Now, how do you know their member? They have the general formula. They have the general formula. Formula CnH2n plus 1 OH. Look at it very well. Look at it. You are having the alkyl attached to the OH. Remember that CnH2n plus 1 is alkyl group. It's alkyl. So when you have OH attached to alkyl, that is alkyl alcohol. Alcohol can be defined as alkyl alcohol. That is, you are having alkyl attached to OH. It is the hydroxyl OH that is functional in alkanols. So their functional group is ROH. The OH is their functional group in alkanols. Don't forget, ROH. Look at their members. And as you study chemistry in advanced level, if you told that the OH can also be attached to the phenyl group or arene group in the A level. Now, let me explain better. You will come to know that there's a cycloalkanes or the aromatic hydrocarbons where you have OH being attached to something of this. And you see that this is our phenol. This is our phenol. It can also occur as phenyl, ARON. So here we are having OH attached to phenol. We call it phenol. That phenol comes from removal of one hydrogen from benzene. Benzene is our benzene. I will teach you more about. I will talk about benzene. Very soon. So that I will talk about benzene If you remove one hydrogen from benzene, this is phenyl. This is phenyl. So by the time you now attach OH to phenyl, you call it phenol. So by name, this is phenol. It's phenol. So you remove one hydrogen from benzene to get phenyl. By the time you now add OH to phenol, call it phenol. So to tell you that, you can see how OH attached to the cyclo group, the same trend. They are still members of the alkanon group. Now, some of the members which I want you to know about alkanols, look at it. From our general formula CnH2n plus 1 OH, our when n equals to 1, I told you, we have CH3, our methyl with OH, I call this one methanol. We call it, some tell we call it methyl alcohol. Methyl alcohol. Our methylated spirit. That's where you get it. Methanol, methyl alcohol. When N equals to 2, I have C2, H5OH. This is our ethanol or ethyl alcohol. Ethyl alcohol. And when N equals to 3, we have C3. This is, don't forget, this CH3 alone is methyl. So methyl with OH, methanol. C2H5 is ethyl. Ethyl with alcohol is ethanol. C3H7 is propyl. Propyl with OH is propanol. Don't forget, this is the trend. C4, H9 is butyl. Is butyl. So when you have butyl with OH, that is butanol. Butanol. Can you see the chemistry? C5H11 is pentanol. Is pentyl. C5H11 is, this is pentyl. By the time you now add the OH, that is pentanol. When it goes to C6, H13, OH is ethanol. This is our ethanol. C7, H15OH is our ethanol. Ethanol. But this one is our, this C7H15 is ethyl. Ethyl. And C8, H17OH is octanol. Octanol. C9, H19OH is nonanol. Is nonanol. C10, H21OH is our decanol. And their members. I will explain to you their function, their physical property and chemical property. Let's look at the next group. I call it alkanoic acid. Alkanoic acid. The alkanoic acid. Alkanoic acid. ROCOH. This is their general formula. This is their functional group. So by read, this is the way we write them. Double bond to O, single bond to OH. Don't forget. Double bond to O, single to OH. So you can ask that. These chemists, they are confusing. They are not confusing. Alkano is ROH. Don't forget. Our alkano is ROH. But the alkanoic is ROCOH. Let me tell you the chemistry behind this alkanoic acid. Our mineral acid is called inorganic chemistry. Inorganic acid. Our HCl, our H2SO4, our HNO3, our H3PO4, they are all mineral acid. Acid you get from the reaction between elements. We call this one mineral acids. These are acids you get from mineral elements. As we call them inorganic acid. Remember we have spoken about them in one of our teaching. But here is organic acid. Acid you get from plants, and they have their origin from plant and animal. They are alkanoic acid. They are the carboxylic acid. They are the carboxylic acid. This is the general formula. This is the functional group. So by general formula now, we have Cn, H2n plus 1 COOH. So what is functional in them is the double bond to O and second one to OH. Like the normal acid, they also donate hydrogen in water. So when they hydrolyze in water, they produce hydrogen. So they behave like the normal acid. Look at their members. So that I want to take note of this member of Akanoiku. The way they form their member is they have different trend from others. Their own end start from 0, not 1. No. Their first member start from 0. If you put 0, everything will be 0. I will take this one as hydrogen. This is their first member. First member is methanoic acid. The first member is methanoic acid, and by structure this is the structure, methanoic acid. So the first member of the acanoic is the methanoic acid. Their n equals to 0. Anywhere you have CH3 from the one we have taught and you have been listening to, CH3 methyl, CH4 methane, but their own CH3 is not methanoic, it's ethanoic. Because the first member is methanoic. So when you have C2, let me explain quickly. When you have C3, H7, COH. When you have C4, H9, COH. When you have C5, H11, COH. When you have C6, H13, COH. Don't ever make mistake to call this one methanoic, because you consider this carbon to become 2. So this one is methanoic. This is our ethanoic acid. Don't forget, students, ethanoic acid. This is our propanoic acid. Propanoic acid. And this is our butanoic acid. Butanoic acid. This is our pentanoic acid. Our pentanoic acid. This is our hexanoic acid. And this is our heptanoic acid. I have reason why I'm giving you many members so that you can familiarize with all this member. The C7 is pronounced as if we are pronouncing it. The C7 is ota. The C8 is nona. The C8 is nona. The C9 is deca. The C9 is deca. Why do I need to talk about higher members? There's need for it. There's need to talk about, in all the group we are with, we don't talk about the higher members. Let me talk about members like C11, C12, C13, C14, C15, C16, C17, 23 COH, C25 COH, C27 COH, C29 COH, H31 COH, H33 COH, H35 COH. Higher member of this group are relevant in chemistry. Octanoic, like I've said, octanoic acid. This is our nonanoic acid. This is our decanoic acid. This is dodecanoic. And this is duodecanoic. Higher members are used. They have their relevance in chemistry. Like this, let me explain the way you pronounce it. You pronounce C12 as if you are adding 3 to 10. You call it trideca. This one is tridecanoic. Decanoic acid. See, this is, you are adding 4 to 10. This one is tetradecanoic. And this one is pentadecanoic acid. And this one is hexadecanoic. And this one is heptadecanoic. And the C17 is octadecanoic. The one that we use in saponification for making soap. Let me just say little that these theory, the C14, the C15, H31, COH, the C16 H33 COH, the C17 H35 COH, they have their relevant. These two are obtained from plants. This is our oleic acid. This is our linoleic acid. And this is our stearic acid. That's why we use this one for producing soap. I'll talk about it in communication. Our soap is sodium stearate. They are obtained from stearic acid. So the higher member of this alkanoid group, they have relevance. That's why I talk about them. Because they are used in making soap. Especially this stearic acid uses in producing. When you add this one to alkaline, you get soap from it. So stearic acid, you also call ultradecanoic. Don't forget stearic acid, ultradecanoic acid. Because this is the IUPAC name. The old name is stearic acid. The IUPAC is ultradecanoic. The old name of C16 is linoleic acid. The IUPAC name is heptadecanoic. The old name of oleic acid is oleic, but the IUPAC name is hexadecanoic. Don't forget. That is. Now another group I want to expose you to is our alkanoids. Our alkanoids. I call them ester by name. They are ester. What are they? Ester are produced from reaction between alkanoic and alkanol. Ester itself is organic salt. When you have alkanoic plus alkanol, they will give us ester plus no. Are you confused? How do we get their general formula? Their general formula there. We said alkanoic is this, alkanol is this. This is alkanoic, this is alkanoic, this is alkanol. By the time you remove acid, always release hydrogen in water. This release OH. When they now combine, it forms RCOR plus water. This is the so-called ester, our alkanoid. Our so-called ester, the alkanoid, and this is the water produced. Our RO can be the same or different. Don't forget, it can be the same. RO can also be different. They may be different. So their own general formula is RCOR. Somebody say that RCOR because we coined the name from alkanoic and alkanoid. Somebody will now say, this ROH, I'm confused, so don't confuse. Remember, alkanol is ROH. Don't forget alkanol. Remember alkanos. Remember alkanoic is RCOH. Alkanoic. Don't forget the alkanoid RCOR is our alkanoid. So don't forget. So alkano ROH, alkanoid RCOH, alkanoid RCOR. So that we have seen lots of questions from WAEC and JAMB. The name is always a problem year after year. How do you get their names? Their members. Very easy. Very, very, very easy. How do you get their member? Very easy. And their name. This ester. You get their name. This. Let's take a case study. This is alkanos. This is alkanoic. Alkanoic. Alkanol. C3. OH. C2. H5OH. C3. H7OH. C4. H9OH. C5. H11OH. C6. H13OH. C7. H15OH. C8. H17OH. The alkanol is COH, CH3, COH, C2H5, they are corresponding OH, C3, 7 COH, C4, H9 COH, C5, H11 COH, C6, H13 COH, C7, H15OH. Now, how do we get their names?
It's always a target in WAEC and JAMB every year.